What are the difference between double salt and complex salt? Double salt is stable only in solid state but dissociate into simple ions completely in solution state. How many number of coordination bond will be present between ligand and central metal atom? That will be considered as coordination number. Oxidation state of the metal ion is indicated by Roman numerical in parenthesis. Parenthesis means in small bracket, and in Roman only the oxidation state of metal should be written. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Now I am going to start a new chapter from the inorganic chemistry part, that is coordination compounds. And in this session we will discuss about classification of inorganic salts, definition of terms related to coordination compounds, coordination sphere, coordination polyhedron, oxidation number of central atom and nomenclature of coordination compounds. This is a huge session, but also they are all interrelated to one topic to another topic. So we will discuss one by one. Before going to classification of inorganic salts, what is the content name? Coordination compounds. Then what are coordination compounds? The compounds in which metal ions or metal atoms are connected to anionic species or neutral complexes are called as coordination compounds. And those coordination compounds are very much helpful for modern inorganic chemistry research. Okay. Before going to the coordination compounds, we will discuss its classification of inorganic salts. Classification of inorganic salts. Inorganic salts are classified into three types, that is simple salts, double salts and coordination compounds. What are simple salts? These can contain one acid radical and one basic radical. Simple salt means you know it will contain one acid radical and one basic radical. Here Zn 2+ and SO4 2-. Okay. One acid radical and one basic radical are present, so it is simple salt. Double salt, it is a mixture of two simple salt. See here, it is one simple salt and magnesium chloride is one simple salt. The combination or the mixture of two simple salt is considered as double salt. More salt is also an example. Here ferrous sulfate and ammonium sulfate are mixed. Okay. Next, coordination compounds or complex salt are the compounds in which the central metal atom is linked to a number of ions or neutral molecules by coordinate bonds, that is by donation of lone pair of electrons by these ions are neutral molecules to the central metal atom. Coordination compounds or complex salt are the compounds in which metal atom is linked to a neutral ions or number of anions will be formed. Those kind of compounds will call it as coordination or complex salt. Next, difference between double salt and complex salt. What are the difference between double salt and complex salt? Double salt is stable only in solid state but dissociate into simple ions completely in solution state. Okay. Double salt in the solid state it will be stable, but in solution state it will get separated into different salt. But complex salt is very much stable both in solid as well as in solution state. It will not dissociate it into number of salt. For double salt example, carnallite and more salt, that is mixture of potassium chloride and magnesium chloride. Here in the more salt, ferrous sulfate and ammonium sulfate. For example of complex salt, ferric hexacyanate and also tetra potassium ferrous cyanate will not dissociate into ferric and cyanate ions. It will dissociate into simple ions. Definitions of terms related to coordination compound. This is overall coordination compound, and here so many terms we have written. You have to understand each and every term to analyze the overall coordination compound. If you doesn't understand the each and every term of the complex, you will not understand the overall coordination compound. Okay. Here one central metal atom is present. Okay. That central metal atom should have vacant orbitals to accept the electrons from the ligands. Okay. That will be central metal acceptor. Okay. And here number of atoms are present, and these ammonia are ligands. Ligands means which donate the electrons to the central metal atom, and here these are all ionizable atoms, and this is coordination sphere, and which will be written in only square brackets included with central metal atom, ionizable atoms and ligands. And this is charge of the complex. Charge of the complex means how much ions have been donated to the central metal atom. If it is equal to 0, that is neutral complex, or sum of the complex with charge means anionic species or cationic charge can be seen. Okay, and the bond between central metal atom and ligand will considered as coordinate bond. This is about the overall coordination compound terms. We'll discuss further again. Coordination entity. A coordinate entity constitutes a central metal atom or ion bonded to a fixed number of ions or molecules through coordinate covalent bonds. Coordinate entity means there is a fixed number in which ligand and central metal atom will be bonded. Okay. See here, for cobalt, 3 chlorine and 3 ammonium ions will be attached. And here for iron, 6 cyanide will be attached, and 4 is a charge of the complex. Next, central metal ion. The metal atom or ion in a coordination entity to which a fixed number of ions or molecules are bound in a definite geometrical arrangement around it is called central atom, and it should be a acceptor, so it will be considered as Lewis acid. Here Na2 plus in nickel complex, that overall Fe3 plus in ferrocyanate complex. Ligands. The ions or molecules bonded to the central metal atom or ion in a coordination entity are called ligands. Ligands are Lewis spaces, means it will donate electrons to the central metal atom. Okay, here cyanide molecules are ligands in that complex. Next, types of ligand. Okay, there are unidentate, bidentate and tridentate ligands. We'll discuss one by one. First, we'll see unidentate ligand. It is a ligand which has one donor atom, that is the ligand bound to a metal ion through single donor atom. See here, like water, ammonia, etc. Unidentate, neutral ligand means water, ammonia, which is a neutral in nature, but unidentate ligand which will donate one donor atom for the central metal atom. Okay, nitrate, carbon monoxide, and these are all neutral ligand but unidentate. Its charge is 0. Next, unidentate negative ion ligand, hydroxyl ion, fluoro, chloro, bromine, bromo, iodo ions and cyanate, NH2 amine, nitrite, nitrate, acetate and oxygen, sulfate, nitrogen. These are all unidentate negative ion ligand which is having the charge -1. Next, unidentate positive ion ligand. So, NO plus and NO2 plus, like that, +1. Next, didentate or bidentate ligand. It is a ligand which have 2 donor atoms. Okay, in ethylene diamine, 2 donor atoms can be seen. So, didentate or bidentate ligand. Polydentate, when several donor atoms are present in a single ligand, the ligand is said to be polydentate. In a single ligand, number of donors should be present, then polydentate. Ethylene diamine tetraacetate like EDTA is an important hexadentate ligand. It can bind through 2 nitrogen and 4 oxygen atoms to a central metal ion. Okay, ethylene diamine tetraacetate, which is a EDTA, which is hexadentate ligand. It can donate 6 electrons to the central metal atom. Next, ambidentate ligand. Ligand which can ligate through 2 different atoms is called ambidentate ligand. Examples of such ligands are nitrate and thiocyanate ions. Nitrate ion can coordinate either through nitrogen or through oxygen. See, nitrato ion will form with or through oxygen and nitrogen, and similarly thiocyanate ion through the sulfur or nitrogen ion. Okay, see here, isothiocyanate, this is nitrato, react with nitrogen and oxygen. Okay, chelate ligand. When a di or polydentate ligand uses its two or more donor atoms to bind a single metal ion. Okay. A polydentate ligand uses its two or more donors atoms to bind a central metal atom. Here this is one central metal atom to bond with two or more ligands. Okay, polydentate ligand. It is said to be chelate ligand. Such complexes are called chelate complexes. Next, coordination number. The coordination number of central metal atom or ion is the number of ligand donor atoms to which the metal is directly bonded. How many number of coordination bond will be present between ligand and central metal atom? That will be considered as coordination number. In case of monodentate ligand, coordination number will be number of ligands. Okay, coordination number 2, see here it will be coordinate geometry as linear. For example, AgNH3 2 or Aurous chloride. This one coordination number 4, square planar. Okay, ammonium palladium. This one tetrahedral 4. Okay, tetraammonium zincate. This is coordination number 6, octahedral geometry. Here hexa amino cobaltate complex will be formed. Next, coordination sphere. The central ion and the ligands attached to it are enclosed in square bracket, which is known as coordination sphere. In this overall sphere, this complex, the square bracket will be considered as coordination sphere. The ionizable group written outside the bracket is called counter ions. This is counter ions which are present outside the coordination sphere. Example, in the complex, the coordination sphere is FeCN6 and the K+ ions are counter ion. Next, denticity. Denticity is defined as the number of coordinating atoms present per ligand. Okay, the number of coordinating atoms per ligand, how much are present, that much will be considered as denticity. Next, coordination polyhedron. The spatial arrangement of the ligands which are directly attached to the central metal atom or ion is called coordination polyhedron around the central metal atom. How the ligands which will attach to the metal on what direction or on what geometry will be considered as coordination polyhedron. See here 6 ligands connected to single metal atom in a octahedral geometry. Here 4 ligands with single metal atom, tetrahedral geometry. Okay, here in square planar, here trigonal bipyramidal and here square pyramidal. Okay, and here also it is on the plane, single line, it is above the plane and this is below the plane. Okay. Next, oxidation number of central atom. The oxidation number of the central atom in a complex is defined as the charge it would carry if all the ligands are removed along with the electron pairs that are shared with the central atom. The number of the charge it would carry if all the ligands would removed. Okay. How much ligands would be removed, that much will be the coordination or that much would be the oxidation number of the central metal atom. Example, the oxidation number of copper here +1 and it is written as copper 1 in parenthesis. Okay. See here, platinum chloride, we have to find out for platinum, it would be considered as x plus 4 will be equivalent to -2 because it is outside the bracket. So what will happen? X, we can take 4 either this side or you can take -2 to this side. So if we take x equal to -4, okay, x equal to -2 or it can happen x equal to +2 also. By we can interchanging the orders. Here we have to find out for chromium x equal to, ammonium is a neutral, so 0 plus 3, chlorine charge is -1, okay, equal to 0. It should be equivalent to 0. For chromium x, 0 into -3 it will be 0 only. So 3 into charge is -1 for chlorine, which will be equivalent to 0, and x minus 3 equivalent to 0. So x will be +3. For chromium +3 and for platinum +2. or -2. Okay, this is how the oxidation number of central atom should be find out. Next, types of complexes. They are homoleptic complexes or heteroleptic complexes. Homoleptic complexes means the central atom, metal atom should be surrounded by same type of ligand, that will be called as homoleptic. See here, complexes in which a metal atom bound only one kind of donor groups are called homoleptic. If we arrange this cobalt, NH3, all the 6 ligands are same kind. So, it is homoleptic ligand. Okay, heteroleptic ligand means complexes in which a metal atom is bound to more than one kind of donor atom. So, if it is here NH3, Cl and Cl, more than one kind of donor atom is present, so it will be considered as heteroleptic. These are the kinds of complexes. Next, table of common ligands. Monodentate, which will be having 0 charge, ammonia, amine, name in complex, amino, water, aqua, CO, carbonyl, NO, nitrosyl, PYR, pyridine, N3, azido, and BR, bromido, Cl, chlorido, Cn, cyanido, F, fluorido, OH, hydroxido, ONO minus nitrito O, NO2, nitrito N, and from azido to nitrito it is having charge of -1 and plus, and here also nitrato, NO3, CH3COO, acetato, SCN, thiocyanato, NCS, isothiocyanato with +1 charge, NO plus nitrosonium, NO2 plus nitronium, NH2, NH3 plus hydrazinium. Okay, in bidentate for 0 charge, bipi, bipyridine, En, ethane 1,2 diamine, -2 charge, CO32, carbonato, O2, oxido, C2O42, oxalato, SO4 sulfato. Like this you have to pronounce when the complexing, the naming of the complexes, and you have to write like this only. Okay. Nomenclature of coordination compounds. Naming of mononuclear coordination compounds. The cation is named first in both positively and negatively charged coordination entities. The ligands are named in alphabetical order before the name of the central metal atom. Means the cation is named first in both positively and negatively charged coordination complex, and the ligands are named in alphabetical order before the name of central metal atom. Names of the anionic ligands end in O, and then those of neutral and cationic ligands are same. Okay, except aqua, amine, carbonyl, nitrosyl. To indicate the number of the individual ligands, the prefixes mono, di, tri, etc. are used. If these prefixes are present in the names of ligands, then the terms bis, tris, tetrakis, etc. are used. Okay, usually bi, tri, tetra should used. If the names already it has been present means you have to termed as bis, tris, tetra. Okay, for example, here NiCl2 triphenyl phosphine is present. So what you have to name? Dichlorobis triphenyl phosphine nickel. Okay, metal atom should be in last with coordination number. Oxidation state of the metal ion is indicated by Roman numerical in parenthesis. Parenthesis means in small bracket, and in Roman only the oxidation state of metal should be written. If the complex ion is cation, then the metal is named as element. For example, Fe in a complex cation is called iron and Pt is platinum. Okay. Nomenclature of it still continues. If the complex ion is anion, then the metal is named with suffix ate ending. For example, CO, complex anion is called cobaltate. For some metals, Latin names are used in complex anions, ferrate for Fe. The neutral complexes molecule is named as the complex cation. Okay. See here, platinum is central metal atom, diamine, because amine will get first alphabetical order A. So diamine, chlorido, nitrato, N platinum and having oxidation number 2. Okay. Here potassium, you can, that counter ions you can take first or last. Potassium trioxalato chromate 3. Okay. Dichlorido bis ethane 1,2 diamine, En means 1,2 diamine, cobalt 3 chloride. Pentaamine carbonato cobalt 3 chloride. Means after the square bracket you have to write last. If it is before square bracket you have to write first, like potassium here. Okay. Mercury tetrathiocyanato cobaltate 3. Tetracarbonyl nickelate nickel 0 because it is neutral complex. Triamine triaqua chromium 3 chloride. Okay. Triamine triaqua cobalt 3 chloride. Potassium tetraaqua zincate 2. Okay, this is how you have to name the complexes in coordination chemistry. We'll see here. First, which one? Triamine, triaqua, and there should be no space at all. Triaqua. Okay. Chromium. It is having the oxidation number 3. Next, chloride. Triamine, triaqua, chromium 3 chloride. This is how you have to name the coordination complex. Next, nomenclature of coordination compounds. From name to how you have to write the complexes. Formulas of mononuclear coordination compounds. The following are the rules to write the formulas. The central metal atom is listed first. Okay. First you have to write the central metal atom. The ligands are then listed in the alphabetical order. Polydentate ligands are also listed in alphabetical order. In the case of abbreviated ligands, the first letter of the abbreviation is used for the determination of the position of the ligands in the alphabetical order. Ligands you have to name it in alphabetical order. The formula of the entire coordination entity is enclosed in square brackets. Ligand abbreviations and formulas for polyatomic ligands are enclosed in parentheses. There should be no space between the ligands and the metal within a coordination sphere. For the charged coordination entity, the charge is indicated outside the square brackets as a right superscript with the number of before sign. The charge of the cation is balanced by the charge of the anion. See here, tetraamine aqua chlorido cobalt 3 chloride means chloride you have to write outside the box. Okay, cobalt at the last, so you have to write first because it's a central atom. Next triamine, okay, tetraamine, next aqua chlorido. Okay, zincate, so potassium first you have to write outside the box, zinc central atom, tetra aqua hydro, okay, OH. Potassium trioxalato aluminate means first you have to write central metal atom. Dichlorido bis ethane means En 1,2 diamine, cobalt 3. Tetracarbonyl nickel, tetraamine aqua cobalt chloride. So potassium tetracyanonyl, tris ethane 1,2 diamine, chromium 3 chloride, amine bromido chlorido nitrito platinate in coordination number 2, dichlorido bis ethane 1,2 diamine platinum, later nitrate, iron, hexacyanoferrate 2. Okay. So this is how from the name you have to write the complexes. This is about the overall coordination chemistry introduction part with nomenclature. And in the next session, we'll discuss about isomerism in coordination compounds. So we'll meet in the upcoming new chapter. Till that, thank you.